So guys, in this video today, I'm going to go over the review for quiz 9. So these were the answers. So in case your teacher didn't post this, you can look these over first. You could pause it here, check your answers. And then if you need to see a specific problem, you can go to that problem and see me work it, okay? So this is 1 through 3, and it says add and subtract the following rational expressions. So the first problem, notice that it has a common denominator, and that's what we're looking for. All three of these is a common denominator. Okay, guys, that's always going to be what we're looking for when we're adding and or subtracting rational expressions, okay? So here we have a 24y, so that's going to be our denominator, and then because it's the denominator of both, we can just add or subtract across the top. So this is 4x minus 6y minus 6x, right? So 4x, our like terms here are 4x and negative 6x, right? So that's going to be negative 2x minus 6y over 24y, okay? So now here's the deal I need you guys to see, is everything in this, every term in this expression is divisible by 2. Do you guys notice that? So that means we can reduce everything in this expression by 2. So it's going to be negative x minus 3y over 12y. Now the reason we cannot divide everything by y is because every term does not have a y. So this is our final answer, okay? Now the other thing that we didn't talk about here is when are these expressions, the x values or y values excluded. Here the y value would be excluded, and it would be when y does not equal 0, right? Because we would set 12y equal to 0, divide both sides by 12, right? So y cannot equal 0. We wouldn't even have to worry about x because there is no x in the denominator of this problem, right? So the next one has different denominators. You guys notice that? So when that's the case, we're going to have to multiply by the opposite one. So I'm going to rewrite the problem first. So we got 7 over 3x plus 1 minus 6x over x minus 3. So I want to multiply the first expression by x minus 3 over x minus 3 because I need to get that in the denominator of my first term. And then the second term, I'm going to multiply by this denominator, right? So we're going to multiply that by 3x plus 1 over 3x plus 1. Now notice we have the same thing in both. Notice the terms are the same now, and that's what we're looking for, is getting the terms the same, because then we can just put the whole expression over the x minus 3 times the 3x plus 1, right? Okay, so now what we want to do is multiply. So we're going to multiply. I'm going to go ahead and put this over that. X times 7, so that's going to be 7x. Negative 3 times 7, so that's going to be negative 21. Now, what I like to do here, guys, is I like to attach this negative to that first term, or change the signs of that whole term, whichever may be the case. So in this case, we're going to multiply negative 6x times 3x, so that's going to be negative 18x squared. And then we're also going to multiply it by the 1. So negative 6x times 1 is negative 6x, right? So here again, we're looking for like terms. So we don't have anything else like the negative 18x squared. So I'm going to write it negative 18x squared. We do have two x values. Y'all see that? So we got a 7x minus a 6x. So that's going to be minus x. And then we also have a constant left, right? Just this one constant right there. We don't have another one. So that's negative 21, okay? So now that all goes over, again, our common denominator, x minus 3, 3x plus 1, right? So what I'm going to do, just to check, is I'm going to multiply these by each other. And I'm trying to remember, y'all, it was like 370 something. And there are no factors of that number that add up to be negative 1, okay? So that's what you guys are checking for, to see if there's any factors of 18 times 21, or negative 18 times negative 21. This was 378. Well, obviously, there's no factors of 378, y'all, that add up to be negative 1. So this is our final answer. Now, the only other difference is this could be multiplied out, right? And if we multiply that out, we're going to get x squared, 3x squared, minus 8x minus 3. That would be our denominator. So that would be the only potential difference in the way that the answer looks, okay? All right, so this next one, we're going to factor the denominator over here. So if there's something that's not factored, we want to factor it, okay? So this is going to be, what are the factors of negative 7 that add up to be 6. That's going to be x plus 7, x minus 1, right? So we're going to rewrite this x plus 2 over this x plus 7, x minus 1, right? So then what I want to do is I want to make sure that the denominator of the other term is the same. So we're adding to it, again, the 2x over x minus 1, right? So what do we have to multiply by x minus 1 to get the same denominator? The x plus 7, right? So we're going to multiply over here by x plus 7 over x plus 7. So once again, what is x times 2x? That's 2x squared. 7 times 2x is plus 14x. Then we're adding an x and we're adding a 2, okay? All of that is over what? Our x plus 7 and our x minus 1, okay? So now we need to combine some like terms here. Y'all see these like terms right here? So we get 2x squared plus 15x plus 2 over x plus 7 and x minus 1. And again, if I asked you, where is x undefined here? I didn't do that over here, y'all. If I did that, I would set these equal to 0 and solve. Our undefined values here would be -7 and +1, right? Because again, we'd set both of those equal to 0. So our question here again is, are there any factors of a times c, which would be 4, that add up to be 15? And the answer is no. So we can't factor this answer anymore, okay? So that would be our answer there. All right, the next one says, given f of x and then the equation, and g of x and then the equation, find f of x divided by g of x. Okay, so remember, we're going to do this first. We're going to do our keep, change, flip, right? Keep our first term, change our sign, and flip the second term. So I'm going to go ahead and factor this first term, y'all. Okay, so this is going to be a plus 6 and a plus 9, because 6 times 9 is 54, and 6 plus 9 is 15. And then I'm also going to factor out that 6 in the denominator, so that's going to be a plus 9. Now we're going to change it to multiplication. We're going to flip this now. So we're going to put our a plus 8 on top, and we're going to factor this one as well. So what are the factors of 42 that add up to be -1, right? So that's going to be a plus 6 and a minus 7, right, guys? Okay, so now we're going to scratch out, we're going to mark out the ones that are repeated in the numerator and denominator. So we've got a plus 6 and a plus 6, and a plus 9 and a plus 9. So what are we left with? We're left with the a plus 8 in the numerator, and we're left with 6 times a minus 7. Now here again, the answer could also be a plus 8 over 6a minus 42. Same answers, y'all. It's just what is occurring here. Now this one, I had several questions about number 15, y'all. So this is actually equal to, people didn't understand what this was telling them to do. It's really telling us that we're going to take f of x times g of x, okay? That's what this problem is telling you to do. So once again, we're going to factor our numerator here. So x squared minus 4, isn't that x plus 2 and x minus 2? Remember, we take square root of both sides of the perfect squares, put a plus and minus between them. That's over x minus 5. And then we're going to multiply that by, again, we're going to factor our numerator here. So what are the factors of 35 that add up to be -12? That would be x minus 5 and x minus 7. And then what are the factors of -14 that add up to be -5? So that would be x plus 2 and x minus 7, right? So now we can cross out what's repeated in the numerator and denominator. We have an x plus 2, x plus 2. We have an x minus 5 and x minus 5. And we have an x minus 7 and an x minus 7. So the only thing that's left, y'all, is that x minus 2. Now, let me just bring something to y'all's attention here. If this had been flipped and the x minus 2 had been in the denominator, then it would be 1 over x minus 2, okay? Just remember that, okay? So this next one says solve, okay? So what we're going to do on this one is we're dividing by a binomial with a first degree binomial with no leading coefficient, or leading coefficient of 1, okay? So this means we can use synthetic division, right? So notice we have an x to the third, but we do not have an x to the second, so we're going to have to put a 0 where that goes. So we're going to put a 1, a 0, a -8, and a 12. And remember, we're going to set this equal to 0, and so this is going to be x equals 1, right? So we're always going to change that sign, right? Bring down the first term, so 1 there, then 1 times 1 is 1, 0 plus 1 is 1. 1 times 1 is 1 again. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 7. And so this is actually going to be 5, right? So that's our remainder. This is our constant right here. This is an x to the first. This is an x to the second. Going to put a plus sign there so I can just see what the answer choices look like. So all of them have an x to the second. This one does not have an x to the first. This one does not have an x to the first. These two do. And then we've got a minus 7 here. Notice that. And a remainder of 5. So our answer was B. Okay? Now, number 7 says the area of a rectangle is given by the polynomial 18x to the third plus x squared minus 41, x minus 20. If the width of the rectangle is represented by the binomial 9x plus 5, what is the length of the rectangle? So area is equal to length times width, right? So if that's our area, then if we're trying to find the length, and we have the area, this is area, right? It says area here, and then our width is right there, right? So that means we're going to divide the area by the width, right, y'all? To get the length. So area divided by the width is equal to the length. So that means that's what we're going to do. We're going to use division here, okay? And this time we're going to have to use long division. And the reason we have to use long division is because of that 9 in front of the x, okay? So I'm going to put 9x plus 5 here, and I'm going to divide it into our 18x to the third plus x squared minus 41x minus 20, right? So what do we have to multiply by 9x to get 18x to the third? That would be 2x squared, right? So that's going to give me 18x to the third plus 10x squared. Remember, again, we're subtracting all this. So that's going to give me minus 9x squared minus 41x. What do we have to multiply by 9x to get negative 9x? That would be negative x, right? So that would give me negative 9x squared minus 5x. So once again, we are going to change the signs of all this because we're subtracting it. So that's going to give me negative 36x minus 20, right? So here again, we're going to multiply, what do we have to multiply by 9x to get negative 36x? That would be minus 4, right? So when I multiply that, I get negative 36x minus 20. Changing the signs again, and that gives me 0 as my remainder, right? So let's check and see which one. All of them have 2x squared, right? So all of that checks out with all of them. But then we got a negative x, okay? So that means this one and this one have to go, right? And then we have a negative 4, so that one goes. So that's my answer right there. Now, y'all see how I did that? I'm checking to see which ones have each term so that I do not get this wrong on the quiz. So be very careful when the answers are this close, okay? That you are being very cautious in how you choose your answers, okay? All right, this next one says simplify. Now, this one we have to look at what a conjugate is, right? So a conjugate is when we just change the imaginary part, right? So what we're going to do up here is we're going to multiply up here, yes, but we're going to change just this part. So it's going to be 6 plus 7i that we're going to multiply by 6 plus 7i. So when we do that, we got 6 times 6i, that's going to be 36i. And then 6i times 7i is going to be 42i, right, squared. Now all of that is over. Now here's my shortcut that I taught my kids, guys. We're going to square both terms and just add them. Okay, that's the quick and easy way to do it. Now, what I know already is that there's no way that that's going to be 13 like A and B are. But let's finish this. Okay, so now remember here too, this changes to what? Negative 1, right? So this is going to be negative 42 plus 36i. And then this is 36 plus 49, which is 85, right? So each of these are going to be over 85. So, which answer was it, y'all? Yeah, it was C. Okay. So this next one says simplify. And with a problem like this, guys, I would just use the box. X minus 3i times, 11 minus 3i. I don't know why I said X, but I'm just going to use the box here to see. 11 times 11 is 121. 11 times negative 3 is negative 33i. This is also going to be negative 33i. And then a negative times a negative is a positive, so that's 9. And then I times I is I squared. We're keeping in mind, again, that this is going to change to a negative 1, right? So notice this time in both our diagonals we have like terms, right? So we have 121 minus 9, and then we have these two right here, which is going to be negative 66, right? So that's going to be, what is that, 112? Yeah, 112 minus 66i. That was our answer here, okay? So number 11 says solve for x. So we are going to distribute this x here. So we're going to have x squared plus 6x, and we're going to move that 14. So we're going to say plus 14 equals 0. So now I'm asking myself, are there any factors of 14 that add up to be 6? Factors of 14 are 1 and 14 and 2 and 7. So the answer to that is no. So I'm going to have to pull A, B, and C here. So A, B, and C, and this A is 1, right? So we're going to use the formula, the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? So I'm going to go ahead and do what's underneath the radical first, because that tells me whether it's going to be what kind of solution it's going to be, real or imaginary, and how many. So I'm going to do 6 squared minus 4 times 1 times 14. So this is going to be 36 minus 56, which is equal to negative 20. So right now, because that's a negative 20 and it's going to go back underneath the radical, right, guys? I can say that that and that are definitely not the right answer. And honestly, I can choose the answer right now because obviously 23 is not 20, y'all. But let's finish it. So what we're going to do is we're going to take our middle term. So it's going to be negative 6 plus or minus. And this is equal to what? The square root of negative 1 times the square root of 4 times the square root of 5. So this is I. And this right here is 2. So that's 2i square root of 5, right? It's going to be plus or minus 2i square root of 5 over 2 times 1, which is 2. And then notice that things are going to reduce, right? So our final answer is going to be negative 3 plus or minus I square root of 5. Because again, notice this reduces and so does this, okay? All right, so this number 11, we're going to rewrite it. 25x squared plus 31 equals 0. I'm going to subtract 31 from both sides. So that's going to give me 25x squared equals negative 31. Then I'm going to divide both sides by 25. So now I get x squared equals negative 31 over 25. Now what I told my students was, we got to take a square root over here, right? So I'm going to take it to both the top and the bottom, okay? So this up here is going to be equal to the square root of negative 1 times the square root of 31, right? And this is just going to be the square root of 25, right? So isn't that going to be I square root of 31 over 5? And remember, we got a plus or minus out front, right? So which answer was it, guys? Yes, A. Okay? Because I had the I. This one did not have an I. Did y'all notice that? Okay, so then the last one says, or number 12 says, identify the number of solutions the following quadratic has. So we're going to use b squared minus 4ac. And we're going to keep in mind that when this is positive, we get what? 2 real. When it's 0, we get 1 real solution. And when it's negative, we get what? 2 imaginary, non-real, complex solutions. Those are interchangeable terms. So we're going to actually set this equal to 0 first. So it's going to be 5x squared minus 12x plus 11 equals 0. So we're going to pull our A, our B, and our C. So this is going to be negative 12 squared minus 4 times 5 times 11. So that's going to be 144 minus 220. So I can already tell without even finishing the problem that it's going to be imaginary because obviously negative 220 is bigger, right, y'all? So that's going to actually be negative 76. So this is going to be an imaginary, or we could say non-real, or we could say complex solution, right? And there would be 2 of those. All right, so this says identify the following characteristics of the given graph, okay? So on this problem, remember, if the end behaviors go in opposite directions, which this does because this is going down and this one's going up, right, then it's going to be odd. If they're going in the same direction, it's even. I always look at the right side, y'all, to determine the leading coefficient. So if it's headed up towards positive infinity, which it is, right? So it's going to be a positive leading coefficient. If it was going down, it would be negative, okay? Then it's asking us for the multiplicity at the root -1. That's right there. And that looks even to me because it's bouncing off the x-axis, right? So that's even. Then notice we have this x plus 1 over here squared. So that's our first term, x plus 1. And we changed the sign of that, remember? Okay, now this right here is x plus 0, and it's just slicing it, right? So it's going straight through it. So this is just going to be an x. And then over here, again, we have an x minus 4. And remember, we always change the sign. And that's also squared because, again, it's bouncing off the x-axis. So it's x minus 4. And here's our check, y'all. We think this is odd, right? So 2 plus 1 plus 2, isn't that 5, y'all? And that actually is an odd degree polynomial. Then it says, as the x values approach infinity. So as I'm headed this way on the x-axis, y'all, where are my y values headed? This is y values, right? So isn't this also headed towards infinity? It is indeed. So it's positive infinity. You could put plus infinity or just infinity. All right, so let's look at this next graph. A student is told to sketch the graph of a polynomial p of x. The function has an even degree. Well, obviously this is even because both ends are headed down, right? Okay. And then a negative leading coefficient, so our right side is headed down, so that's true. It says as x approaches negative infinity over here, that's negative infinity. P of x approaches negative infinity and is, right, because it's headed down, so that's true as well. And then the equation in factored form is P of x is equal to x minus 1 squared. Okay, so shouldn't this be x plus 1 squared, y'all? This should be x minus 2 to the third, and this one should be x minus 4 to the first, right, y'all? So, looks to me like there are a couple errors in this graph based on the equation that we're given. Do y'all notice that this is a minus and this is a plus, and that's not what I have over here, guys? Look right here. I got a plus there and I got a minus there. Those are not the same. Y'all see it? So, the graph, obviously, what we graphed was different than what with the equation they gave us. So this was the answer right there, okay? So the last one says the volume of a swimming pool is given by, so volume is equal to length times width times height, right? If the height of the pool is given to be x minus 4, what are the dimensions of the rectangular base of the pool? So that would be length times width, right? So we are going to divide the volume. And we're going to do this with synthetic division, y'all, because this isn't x with a 1 and a 1 as the leading coefficient and the power. So that's going to be positive 4, right? Then we're going to go 3, negative 4, negative 28, and negative 16. Bring down the 3. 3 times 4 is 12. 12 minus 4 is 8. 4 times 8 is 32. 32 minus 28 is 4. 4 times 4 is 16. So our remainder is 0. Now what I'm going to do is I'm going to actually, this would be our constant, this would be our x to the first, this would be our x to the second, and I'm going to put some pluses in here. That's the equation, okay? So now one of those represents that equation. So what I want to do is I want to go ahead and factor this. So we could use bottoms up or we can use another method. I'm going to show you both, okay? So I'm going to use bottoms up first. So we're going to multiply a times c, that's 12, right? So we're looking for the factors of 12. To add up to be 8, right? So that would be plus 6 and plus 2. And if we're using bottoms up, we're going to divide both of these by 3, right? So this one reduces to be x plus 2. And if we use bottoms up, this goes up here because it doesn't divide. So that's 3x plus 2. Now, if you want to use another method, here's another method. You can drop the 3x's in both sets of parentheses. And again, you're going to do your two factors, which would be plus 6 and plus 2. Now, this one can't be reduced, so it stays like it is, but this one can be reduced by 3, right? So this is still going to be x plus 2, right? And it's going to be 3x plus 2. So it doesn't matter which method you use, but there's an example of both, okay? So where's our answer, though? Yep, it's A, okay?